would like to invite Christa Brelsford to come on up and just start loading up her screen now. Christa is a research scientist at Oak Ridge National Laboratory, which, as you know, is outside Knoxville, Tennessee, and Oak Ridge, Tennessee. And they've been just so pivotal in creating data sets and serving the public and analyzing data that it's really great to have three people here from Oak Ridge today. And her talk today is called Strategies for Validating Digital Trace Data.
So yeah, Cleo, thank you so much for organizing this. I think this is a really exciting and an interesting symposium. And yeah, I'm happy to be here. What I'm looking at today is the new SafeGraph data, just like everybody else. One of the things that I've been wrestling with is sort of how good actually is the SafeGraph data? What can we learn from it? And I've been more focused on what we can learn about what SafeGraph tells us about the people who are going to POIs rather than the POIs themselves. The motivation for that is many folks have heard of Landscan USA. It's an ORNL-based product that develops gridded population in both nighttime and daytime population. The daytime population has to think about where people are when they're not at home. There's good existing models for where people go to work, for where people go to school and institutions. But one challenge in the Landscan USA product is where do we put the non-obligate population? Where do we put people who are not required to be anywhere? Some of those people are at home, some are in public. And there really aren't any national scale censuses or measures of use of public space or shopping behavior. So we thought that maybe the new SafeGraph data can inform our model in how to think about where to distribute what we call shoppers, even though it represents anybody who's out in public and not at work, school, and who doesn't have to be there. So SafeGraph claims to represent foot traffic behavior, but who are actually the people in that panel? So who's not in the panel, who is in the panel? We know that there are demographic challenges. SafeGraph, who ends up in the SafeGraph data, they don't really tell us. But that's a big challenge. But sort of what I'm thinking about is, well, does SafeGraph, for example, does it represent only shoppers? Does it represent only workers? Somewhere in the middle. And SafeGraph sells itself as being good at representing shoppers. So I feel like we're trying to use SafeGraph data for what it's designed for. And hopefully now that means hopefully we can show something interesting about shoppers in space. So for the purpose of this talk, I'm assuming that SafeGraph is representing shoppers and workers with more or less equal probability. We know that they're not capturing everybody. We're hoping that they capture most people. It's plausible that little blue dot could be anywhere on that line, but we have to start somewhere. So for the purpose of this experiment, what I'm doing is, so let's suppose we assign anybody in these sort of hot pink columns to be workers, anybody with a visit duration to a place of longer than 4 hours. This clearly is not very good, but we hope it's at least a systematic way of separating shoppers and workers. Then the question is, do we believe that, or what do we get from that, and do we believe it? We can look at the distribution of visit durations from the SafeGraph data by the building use types of the block groups they're in across different states, across all sorts of different geographies. This is what the shopper worker ratio that I created looks like at the county scale. I didn't map counties with populations of less than 10,000 just because that makes the map super weird. And is this any good? I don't know. We don't have a very good way of validating this because there are so few broad spatial measures of where shoppers are. But it looks like there might be some spatial patterns. Like if you look in here, this is Chicago, and if you really squint, I don't know if the graphics are even sort of high enough over the internet for you to see, but it kind of looks like maybe the suburbs around some of these major cities have higher shopper worker ratios than center cities. We can look within block groups. This is one state because you can't look at a national scale map of block groups. And again, it looks like maybe there's some spatial structure to this shopper worker ratio. But again, do we actually believe these results? Because it's not useful if it's just garbage. So we have to think about what kinds of patterns we actually expect in this shopper worker ratio, and in comparison to other data that we do actually have. So some of the hypotheses that we might have we think safe graph inferred workers should be distributed consistently with known measures of workers. Workers might be located in places with office space. Shoppers might be located in places with lots of retail space. There might be spatial patterns in the shopper-worker ratio based on urban form. And then finally, at the zooming all the way into the POI scale, obviously we can't individually validate all 4.5 million POIs that SafeGraph spits out, but we can look at some of them and do the inferences on shoppers and workers, and the ratios there make sense for POIs that we understand well. So some of the data I'm using for validation is loads data on employment, and then buildings data, which is a good measure of building space by use classification that then I've aggregated up to the block group, or my colleagues really have aggregated up to the block group level. So if we just compare at the block group level, the SafeGraph inferred shoppers and workers by block groups, we see a really, really tight correlation. The R squared, if you put it in log scale, it's 0.9. In this figure, I'm showing a linear and a log scale just to demonstrate that I don't think this is really valid as a scaling plot. But if you plot the range in the data is so big that if you plot it on a linear plot, you really can't see anything. 90% of the data is in like this itty bitty little corner there, and that's not very interesting. So there's a super strong correlation between shoppers and workers, which automatically makes me a little skeptical. I'm not sure that with this strategy, I'm doing much better than just saying, I think maybe all the blue-eyed people are workers, which would give you a really, really tight correlation like this, because if we're accurately separating workers from shoppers, then we'd expect to see some spatial structure. Now, if we compare the SafeGraph shoppers to loads workers, which is a measure of workers that we believe a lot better, the correlation is a lot wider. It looks like there's more structure there. Now, because the correlation between SafeGraph shoppers and SafeGraph workers is so tight, this figure looks almost identical if I replace the SafeGraph shopper years with the SafeGraph worker years. So we can't use when I would expect the correlation to be tighter between loads workers and SafeGraph shoppers than loads workers and I would expect the correlation to be tighter between loads workers and SafeGraph workers than loads workers and SafeGraph shoppers. And I don't see that, which automatically makes me a little skeptical about what my results are. So we can look at these correlations systematically. This is a matrix where each little box here is comparing one of my measures. The SafeGraph measures are highlighted in this sort of yellowy orange. Census-based measures, population, and the loads worker population are in the green, and then the physical building space is in gray. And then each little ellipse in the box is a visual marker of how tightly correlated these different data sets are. And again, you can see that the shoppers and workers are very, very tightly correlated. Shoppers and total visits are also extremely tightly correlated. But there's not really any difference between how shopper years and worker years are correlated with any of the other factors that we can measure. In fact, if anything, shoppers are more tightly correlated with factors that we might expect to be associated with workers than workers are. So I'm a little worried and I'm a little skeptical. But this is a huge data set, and it seems like we might be able to see some signal. So another way of looking at this, this was a result that I was disappointed about. Another way of sort of trying to separate out what's going on with workers and shoppers is say, okay, let's look at how many shoppers there are in block groups dominated by retail space and in block groups dominated by office space. We might expect, as I said earlier, we'd expect that there would be more workers in office dominated space and fewer shoppers, but we empirically so far see the opposite. This is a figure where retail dominated block groups are in this blue and office dominated block groups are in red. And it ought to be that if our hypothesis that shoppers show up in retail dominated spaces more frequently than workers, these colors should be swapped. This figure only shows the relatively few block groups where more than 75% of the block group building space is classified as retail or office. But if you look at it in a continuous way, we see the same result, almost even more extremely, that there's a strongly significant negative correlation between sort of the shopper years and the share of the building population in that block group that's classified as retail. And then finally, we do at least see a little bit of structure here, that as I mentioned, that it looked like from the national scale map, there's a little bit more shoppers in sort of fringe metro areas in the suburbs, and a little bit fewer shoppers in sort of non-core rural places. And these are all sort of different ways that I'm working through to try to identify whether what SafeGraph data claims it's best at, which is identifying where the shoppers are, is good enough to infer anything about shoppers, anything about where shoppers are distributed in space, or where the non-obligate population is distributed in space. So this is very much a work in progress. If anybody's got any other better ideas for thinking about the ways in which we can validate SafeGraph data, especially about sort of who's visiting, and how to think that through, I would be delighted to hear your thoughts. Thank you.